Hi, welcome everybody. We're here to talk about SmartNICs and moving to next generation 25 gig, 50 gig, 40 gig, 100 gig in the data center. I am Anita Trackler. I'm a product manager for Red Hat, focused on NFV and networking.
Hi, and I'm Nick Dasanovic, and I'm VP of Solutions Architecture at Netronome, and I'm focused on SmartNICs and NFV. Actually, I'll start with the... So Anita's going to talk in detail about some of the options for server-based networking data path implementation. But I'm going to start off with a description of the problem statement. So everybody's seen this chart about global network traffic exploding, right, going off the chart. The point I want to make here is that the problem's even worse for NFV, because in data centers implementing NFV, we're doing a lot of service chaining where traffic is bouncing back and forth between different services running in different VMs and containers. So east-west traffic is growing even faster than this graph shows. On the right side, we see that silicon is not getting any cheaper. In fact, the costs are leveling off, and we're not getting the benefits of Moore's law. And that means that we need to be very, very smart about the way that we implement data path functions to get good cost in the data center. So, Anita?
And here's the data path options that we have today for 10 gig servers. We're talking... With OpenStack, our default configuration is openvswitch with the kernel data path. And this one gives you a ton of features, switching, bonding, overlay, but your performance does not meet what you want. If you want higher performance, you got to move to the right. And this is what we have today in deployment for NFV, a lot of SR-IOV. And this is hardware dependent on your NIC vendor, but you can get line rate. You can get line rate 10 gig. But if you want any switching options, you're dependent on your top-of-rack switch. There are no switching options. Moving more to the right, which is new GA for Red Hat OpenStack, is openvswitch, OVS-DPDK, with the data plane toolkit. With that, you can get direct I/O to the NIC and some switching options, bonding, overlay, some overlay offloads. But you have to give up a few cores on your host to be able to do DPDK, entirely devoted to pole mode drivers. So if you want to go beyond 10 gig, 25 gig, and 25 gig and 50 gig is the new 10 gig in the data center. And if you want to go there and you have 25 gig servers, we have to move to OVS Offload as our new next-gen technology. What is Red Hat and what are all our NIC vendors doing? We are working with multiple NIC vendors to get OVS Offload both in the kernel and in OVS and in DPDK. Our goal is make sure we have everything upstream, all drivers upstream first, and to integrate with OpenStack, that's a must as well. And our goal is to standardize the API, both in the OVS kernel, in the OVS DPDK, and OpenStack.
So a little bit about SmartNICs. So SmartNICs' sole purpose is to accelerate and offload the server networking data path. So Netronome is a vendor of SmartNICs, and there are many models for offload, as Anita just alluded to. Basically, at a high level, what we're doing is moving functions that are traditionally implemented in the server data path, either in Linux or in something like openvswitch, for instance, where we're doing complex functionality involving overlay processing, traffic classification, QoS, security rules and policies, and things like that, that are not typically done in the NIC card today. The SmartNIC actually does do those things, and so we are actually moving that functionality from the server, into the SmartNIC as shown in this diagram. And what we're doing is bypassing either partially or completely the server networking data path, which is eating up CPU cycles in the server, bogging down the server and actually creating a bottleneck that's in many cases starving, in the NFV case, starving the VNFs that are trying to execute on the server. So the SmartNIC pulls all of that down into the NIC card itself. In this particular case, we're showing it being implemented in the Netronome flow processor, which is our silicon, purpose-built silicon that's designed to implement the SmartNIC functionality. And Anita's going to go into more detail now about how this is done.
So over here, we have a use case that we're working on today with a number of NIC vendors. The SR-IOV with OVS Fallback. So you have SR-IOV, so this is merging the worlds of OVS and SR-IOV. So you have SR-IOV VFs directly to the VNF, but you also have a PF, a physical function going into the OVS bridge. And so you have now OVS in two locations. You have OVS in the kernel and you have OVS in the NIC. You have two OVS versions and you're offloading your control, your OVS control is now going to offload using TC Flower, which is the traffic control piece in the kernel. It's going to decide which flows are going to be offloaded to the switch, and some flows will continue to stay in the OVS bridge on the host. So there are some features. So most of the white features, the features in white are already being worked on and available. Some of the advanced connection tracking and fallback to OVS are not supported by all NIC vendors. This is on a case-by-case basis. These are Virtio options. If you're not interested in SR-IOV and you want to do live migration, then these are some of the Virtio options. And Nick will go into a few more as well. But this is, if you're using, you want to use OVS-DPDK and you want to do a partial offload. So the whole flow is not offloaded, but you want to take advantage of NIC vendors like Netronome are providing. QoS, security groups, conntrack, overlay offload, you could still do that and still have pretty good performance. Or you can do another option with another NIC vendor is looking at where they're moving your OVS completely into the NIC. There is no OVS in the host, and then you have to worry about tighter integration testing because now you have to deal with OpenStack talking directly to the NIC or through an SDN controller.
Yeah, and then briefly, this is these are the models that Netronome is very focused on. So we have basically a user space agent, which is a relay agent that implements the Virtio backend and talks to VMs. So VMs see a nice Virtio vendor agnostic interface that's very good for live migration, but you get the very, very high performance of the SmartNIC. So that's our model on the left that you're seeing there. And Netronome supports that today. And then we're moving to a model on the right which will provide the same functionality in terms of Virtio and live migration, but the relay agent now moves down into the silicon, so it's even more efficient. Anita?
I will not go into depth in this since we're running out of time, but these are the open source communities that we have to work with. And you can see everything in white is going to be either delivered or shortly delivered. Everything in yellow is still a work in progress, and some of it is in the design phase. Just looking quickly at the advantages and limitations. Yes, we can get line rate, especially if you're using SR-IOV. If you're using any kind of Virtio, there will be some performance hit, but not as bad. It has to be benchmarked. It's not as bad as doing pure OVS. You have all the advantages of all the offload capabilities, and in some cases, you may have fallback. You have option to fall back to OVS if you're having control plane traffic, or you have a failure, or you've exceeded the capacity of the NIC. There are some limitations, of course. Using OVS Offload, you may need to do certification every time a new OpenStack or a new OVS releases to make sure your NIC vendor is compliant with the latest one. Your bonding is limited now. You cannot go across NIC. You have to do within the same NIC bonding. Your feature availability depends on your NIC firmware. So you need to make sure your NIC firmware is updating at the pace OVS and OpenStack are updating. Virtio for live migration is needed. You need Virtio. You can't do it with SR-IOV. And there are different options with that. And then you have varied flow capacity based on your NIC vendor and how much memory or cache is available, and whether you're running conntrack or other security options. And there's a 5-tuple match. I think we're done. Any questions? Yes, go ahead.
Right, as I said, it's not supported today. It's a future direction for Netronome. It's upcoming release, right? That's the situation with Virtio. The driver is not yet decided whether that will be a separate version or not. Do you have any timelines? Is it this year or next year? You can come see me after the talk.